So now we have double angle formulas, so we can use them. And actually in this problem, they're going to have us use all three of them. So that will be fine. We can write them down. So we know the sine of 2 theta is 2 sine theta cosine theta. So that's that one. And we know cosine of 2 theta. I'm just going to use the cosine squared theta minus sine squared theta. You could use one of the other forms if you wanted to, but I don't think it matters too much which one you use. And then my tangent 2 theta, see if I can remember that one, that's always the hard one for me, is 2 tangent theta over 1 minus tangent squared theta. I'm going to double check on that minus sign, but I'm pretty sure it's minus. Yeah. Okay. So those are just the formulas that we did, that we talked about. They're in your book in a chart as well. Okay, now we're going to look at the example one here. Given that, and they tell us the tangent of theta, they also tell us that theta is in quadrant 2. Find the following. Okay, so everything we need to know is in terms of theta. Sine theta and cosine theta, that's what we need to know. Tangent theta, like we could do this one. We already know what the tangent of theta is. But this is all about drawing triangles, okay? So we've done this before, but here we go again. It's in quadrant 2. They need to tell us what quadrant we're in because there's always 2 quadrants where things are positive and 2 quadrants where they're negative. And so we have to know which quadrant we're in so we know if it's positive or negative. So we're in quadrant 2. So I'm going to just draw an angle. Doesn't really matter what it looks like. It doesn't even matter what the angle is. We never actually in these problems, in this problem here, we're never actually going to find what theta is. That's something we do at times, but we're not going to do it here. So I'm going to draw a triangle. The angle where theta is going to be right here. It's going to be that reference angle for theta. Okay? So I have this triangle going on here. I could have stopped it here, but I let my ray continue on there. But it's this idea of that point having an x and a y, and then I have a triangle that has a hypotenuse, an adjacent side, and an opposite side. Okay? So my opposite side, well, let's talk about tangent. Tangent is opposite over adjacent, right? Okay. Now, you only get one negative side, but because you're in the second quadrant, you know the x is negative, right? Okay, so it's going to be a -4 here, and it's going to be a +3 here, okay? So the opposite side, this is the opposite side, and this is the adjacent side. Okay, I'm not really sure where your questions are, so I just like to cover everything. Okay, using the Pythagorean theorem, then, you can figure out the hypotenuse, because you know you have a squared b squared, and it's got to equal c squared. It's a right triangle. So you can plug all that in. 3 squared plus -4 squared. Forgot the square. Okay, so 9 plus 16, which is 25, which is 5. The hypotenuse is always positive. Okay, when we're drawing these angles in standard position like this. Okay. That tells us then our opposite side, adjacent side, hypotenuse. We can find any of the trig functions we need. Okay, so we'll now go do that. So we want 2 times, what's the sine of theta? So here's my angle, theta, and I want opposite over hypotenuse, so it's going to be 3 over 5. And then I need the cosine, which is going to be adjacent over hypotenuse, which is going to be -4 over 5. And then we're just going to do some multiplying, and I'm going to get -24 over 25. So hopefully that one looks good. All right, then we go to the next formula, cosine 2 theta, which looks a little different, but we know cosine. We just did that one. So it's adjacent over hypotenuse, so that's going to be -4 over 5. But we have to square it, minus, and then we need the sine of theta, which is opposite over hypotenuse, for 3 over 5. And we have to square that as well. So it might need a little more room. 16 over 25 minus 9 over 25 So what's that? 7 over 25. So that would be the cosine of 2 theta, right there. All right, we've got one more, tangent theta, which they gave us that, so we can just plug that in. So we're going to have 2 times negative 3 over 4. I'm writing over here, so I might have a little more room. And then 1 minus, and then it's negative 3 over 4 squared. And we have to do some work here. So what do we get? Negative 6 over 4. Well, I should have just canceled, but oh well, we'll just go with that. And then 1 minus, it's still going to be minus 9 over 4, or 16, sorry. 1 over 16. And then, I'm sorry, 9 over 16. So what's that give us? Well, think of your 1 as 16 over 16. So in the denominator, you're going to have 7 over 16. And then you can invert and multiply. So negative 6 over 4 times 16 over 7. So let's see, 4 goes into 16 4 times. So I think I'm going to get, I was trying not to run out of room, negative 24 over 7. And then that would be the tangent of 2 theta. Okay? So I probably should have written these out. I should have written, I'm kind of out of room now, but it's the tangent of 2 theta. That's what you found. Okay? All right. So that one's pretty fun. Just, there were 3 of them. That's why it took a while.